Hi class, today we're going to look at starch hydrolysis. And so in our agar media we put starch as the carbohydrate. And so if a bacteria has the ability to break down starch with an enzyme that it secretes called amylase, then the starch will be changed into glucose, because starch is just a series of thousands of glucose molecules linked together. Okay, and so the amylase will release those bonds and have free glucose. So we would expect that if it is positive for this enzyme amylase, then we would see the loss of the starch. Well, how do you tell if there's starch anymore? So first off, we take we put starch in the plate and no glucose. Okay, so that was the idea behind this. And so we're going to take some powder starch and some powdered glucose. And I want to just show you what happens when we mix it with some iodine. So this is grams iodine. Okay, so it turns black. Okay, here is glucose. Doesn't turn black. So if there's starch present, it will turn black. If there's no starch present, it will not turn black. Okay, so I'm going to flood each plate. So here's an example of number 5 and number 6 colonies. So we just did a snake line of them. And then so everywhere there is starch, when I put iodine on this plate, it will turn black. If the enzyme has been released by the bacteria and broken down the starch into glucose, then it will no longer be black. And so we'll see a clear kind of like a halo around that line of bacteria. So I'm going to flood the plates and then we'll look at the results. Okay, so I'm just going to take a dropper full of iodine and just drip it onto the plate and look for a halo. So I'm going to do this to all of the plates. And I don't have to flood everything on it, just the colonies or the cells. Okay, and then we need to let it sit in for a little bit, and then we'll come back and look at it. Okay, this is number 1. All right, this is number 1, E. coli K12. You can see the snake of the bacteria, but there's no clear zone around it. It's all purple. And so it does not break down starch. So number 3 is on the right, and it has a little bit of a clear zone around it. And so number 3 is Bacillus subtilis, and then number 4, Enterobacter cloacaceae, is on the left, and it doesn't have the clear zone. Okay, so the clear zone is really apparent right in there. Okay, the one on the right is number 5, Enterobacter orogenes, no clear zone. Number 6 is Bacillus megaterium. There is a little bit of a clear zone around the edges there, so that works. And number 7 is Micrococcus luteus, and there is no clear zone. Number 7 is on the right, which we saw on the previous plate, and there's no halo there. Number 8 is Serratia aurantica, and that doesn't have a clear zone. So the top left is number 9, and there's a little bit of a clear zone around it. Number 10 is down on the bottom, and that has no clear zone. And number 11 has a little bit of a clear zone. It's on the right. Number 12 is on the left. So number 12 is Rhodococcus rhodocris, and then our unknown 841 Bravo is on the right, and there's really a good clear zone on the line of bacteria. Okay, and that should be it. So you need to look at these slides and then make your decisions on them and record them, and then compare them to your unknown and help track out your unknown. All right, thanks. Here's the list for the bacteria. So number 1 is E. coli K12, 3 is Bacillus subtilis, 4 Enterobacter cloceae, number 5 Enterobacter aerogenes, number 6 Bacillus megaterium, number 7 Micrococcus luteus, 8 Sarcina aurantica, 9 Aromonas sobria, 10 is Serratia marcescens D1, 11 Micrococcus roseus, 12 Rhodococcus rhodocris, and 841 Bravo is our unknown.